Good afternoon. It is 12:30 and therefore it is time to start today's workshop. My name is Rob Sippel. I'm a librarian at the Evans Library here at Florida Tech. And I'm here to talk to you about plotting and graphing data using Python. And so if you are tuned in today, hopefully that is why you are here as well. A little bit of background as far as why we're doing this today. In the past, I've periodically given talks on basically this subject, plotting and graphing data, but using the R statistical package. And while there's still plenty of people here on campus who are R users and are quite dedicated to R, it's been pointed out to me that a lot of people are using Python these days, and its use is growing very rapidly. And therefore, it might be a good idea if I were to do a workshop on how to plot and graph data using Python as well. And so that's why I'm here today, because I think that was a point well taken. So this is very much an introductory talk. And so depending upon how much background you have in R, some of it, I mean, in Python, some of this may seem a little bit basic to you. I myself am a relative beginner at in Python, so I'm not going to be getting into too much heavy duty stuff. This is really just meant as kind of an overview of how to do some of the basics. So let's start with Python. What exactly is it? And the answer to that would be it's an interpreted high-level general purpose object-oriented programming language. And I think that's a quote straight from the official python.org website. It was created initially by a fellow from the Netherlands named Guido van Rossum. Back in the late 1980s. And he's not as heavily involved in it these days as he used to be, but he's still very much a presence in the Python world. And its home base, as you might put it, is www.python.org. So very logically named website. So if you want to get into Python, using Python, you might want to know how to get it, where to find it. Obviously, one of the places you might go to is that website I just mentioned, www.python.org, which identifies itself as the official home of Python programming language. And another place a lot of people will go to is anaconda.com. And if you are interested in data science or data processing in general, you might find the Anaconda Python package interesting because when you install it, it automatically installs not only the basic Python, but also a series of libraries that are particularly useful for data science. Now, like most coding languages, if you want to code in Python, you could do it with nothing more than a very basic text editor like Microsoft Notepad. And I'm not even talking about Notepad++, I'm just talking about basic Notepad, which is a really no-frills kind of editing software. But I think most people will probably prefer instead to use what's known as an integrated development environment. And essentially, an integrated development environment is a front end that you use for developing your Python product. It just generally makes things easier in terms of your coding, your editing, your debugging, running your code to see if it's doing what you want it, what you intend for it to do. And there are various popular options for doing IDE, as it's known. There's something called PyCharm, another product called Spider. There's Jupyter Notebook. And today I'm going to be mostly showing a series of examples that I've prepared using Jupyter Notebook. And some of the reasons that I like Jupyter Notebook is within a single document, it can let you write and execute and see the results of your code all right there in front of me. So you're not toggling back and forth between the file in which you're doing your editing and then jumping over to see what the website looks like. It's all there in one document, which is kind of handy. It's considered fairly user-friendly for beginner coders, which I am for one, and which you may be as well. And so, as I mentioned, I'm going to be using it today to demonstrate the coding for various kinds of basic plots and graphs. Now, when I first arranged to do this talk today, I was hoping to have the PowerPoint slides and the JUPYTER files and some of the data files in some location that you could immediately download them and maybe even follow along with them as I'm talking today. That didn't work out, but if you want to follow up on this, if you'd like to have my slides or my sample code and the sample data files, I would be happy to share them with you. Again, my name is Rob Sippel. I'm one of the librarians over at the Evans Library. And so if you're interested in any of that, please just let me know. Probably the easiest way to do it would be to just send me an email at rsippel@fit.edu. So rsippel@fit.edu. So if you install Python and nothing else, Python, you can do a lot with Python, but it's almost like when you get a smartphone. You get your smartphone, you take it out of the box, and you can already do some good things with it at that point. Obviously, you can make phone calls, you can send people texts, you can take some pictures, but a lot of us will choose to then go about loading various kinds of apps that let us do things that we're particularly interested in that don't come installed on the basic smartphone. Kind of expands our horizons in terms of what we can do. And Python libraries are very much along those lines. So you can do a lot of basic stuff with Python, but libraries add a lot of additional capabilities to Python. And they'll usually contain various functions that are related to some area of activity in which some part of the Python community wants to work. And I don't know for sure, but I would guess that there are at this point probably hundreds of thousands of Python libraries out there, and the number is growing all the time. Now, for today's examples, there are a couple of libraries that I'm going to be using. For example, OS, which provides functions for interacting with your operating system, and Pandas, which is popular for doing data analysis and manipulation tools. And so today we're doing plotting and graphing, which is basically data visualization. And there are a bunch of Python libraries that are used for doing data visualization. And some of them are matplotlib, plotly, seaborn, ggplot, altair. And there's a lot to be said for all of these. And in fact, each one of these could possibly be deserving of its own workshop. But we don't really have time today to go over all of these. And matplotlib, is a good kind of general purpose data visualization library. Lets you do a lot of the basic kinds of plots that most people will want to do. And for that reason, that's the focus of my talk today. Again, I don't mean to denigrate any of the other libraries. And in fact, if you take a liking to matplotlib and you want to explore the world of data visualization in Python, I would very much encourage you to look into some of these other libraries as well. So what are we going to go over today? Well, start off with some basic stuff, just setting up your working directory. So I'm assuming you're going to have some directory, maybe on your hard drive, maybe on a network somewhere, in which you are keeping, say, your project-related files, which might include, for example, data files. So we're going to work on setting your working directory, importing data from a CSV file, and through most of my examples today, I'm basically working on the assumption that you are probably going to have some data that you need to work with. That data will probably be in the form of, say, a CSV file, which is a comma-separated values file, which you could open up in Excel, for example, but also in Python, obviously. And so we're going to work with a couple of data files that are in CSV data sets that are in CSV files. And we're going to do some things like scatter plots, line plots. I'm going to show you how to specify the size of the figures you generate. Although I didn't list it here, I'm going to show you how to save those to an image file. We're going to talk about customizing figures. So once you want to get a little bit fancier in terms of what your figure looks like, you'll know how to do that. Getting into graphing multiple data fields on a particular figure. I'm going to do a bar graph, a histogram, a box and whisker plot, and then wrap things up with a pie plot. So I mentioned we're going to be working with some data contained in comma separated values files, CSV files. So just to give you a quick sense of what we're talking about today, I've got my first one is called daily min temperatures, parenthetic mini, which is just time series data of temperatures, daily temperatures. So if you look at it on the left, just dates down the left-hand side, temperatures in the right-hand column. The second data set we're going to be playing around with is one called MT cars. This is a pretty popular data set used for practicing. It's one that's also available through R. It comes up in a lot of examples for instructing people on how to do data analysis. So if you look at it there, this is a series of entries corresponding to various cars that were in production in the early 1970s. And it gives you, for each car, it gives you information like the miles per gallon, the number of cylinders, the engine displacement, horsepower. I don't actually remember what D ratio stands for, or what D ratio is, the weight, the time it takes for it to accelerate to, I'm guessing, 60 miles per hour. And VSAM, I don't know what those are, the number of gears, and finally something relating to the carburetor. And then there will be one final data set that we'll play around with that looks at quarterly growth in the gross domestic product for a series of years ranging from calendar year 2011 through calendar year 2020. So at this point, if you had the files that you need to do this, and you weren't just kind of looking on with me, you could start up your Jupyter Notebook file by just locating it and double clicking on it. And that file will be called Python for graphing IPYNB. So obviously you can't do that right now, but I have, so I'm going to jump over to that. So just give me a second while I set that up. All right, bear with me here. I'm trying to, all right, here we go. Share screen. And let's see. Here we go. Python for graphing. So here we are in our Jupyter file, as we call it. And as I said here, this combines both code for getting things done and the output for code. So if you kind of scroll through here, you'll see like here's the code and here's the corresponding thing that you get when you run the code. So, you know, kind of having it all in one place, that's one of the reasons that I chose to do this in this form today. So let's start at the top here. We got some basic code. And I mentioned this OS, which I think might stand for operating system. I'm not sure, but it's one of the libraries. So I'm going to import that library, just basically saying to Python, I want to use this library. And then I'm going to say, okay, within the OS library, I want to execute this command, get CWD, which is determines what your current working directory is. So get in CWD is current working directory. Executing another command within the OS library for changing the directory, CHDIR, and as an argument for that, I'm saying, okay, I want to change my directory to this Python graphing directory within my C drive. And then just to make sure that I'm where I want to be, I executed this command again within the OS library for listing directories. And if you look below this, you see that it lists the contents of that directory now. So you get this series of files, a couple of image files here, like this Beaker test plot PNG, some CSV files as well, another image file down here. So basically, you're seeing what's supposed to be in this directory. So typically, before you can graph anything, you are going to need to import some data. You're going to need to get it from somewhere. So let's just assume in this case, we're getting it from one of our CSV files. So again, at the top, we're going to start by accessing the libraries that we need to do our work here. So pandas, like I mentioned, is good for all kinds of data manipulation. And so I'm saying from the pandas library, I want this specific thing called read CSV. And as the name would suggest, read CSV is used for reading data from CSV files. I'm also saying I want something else. I'm saying from the matplotlib library, I want to import this thing called pyplot. And you're going to see that used in a few seconds here. This matplotlib inline command is just something that makes your output appear nicer within the JUPYTER Python file. And here's one of those cases where the fact that I'm not really an advanced Python programmer comes in. I don't know exactly what it does, but it does help, I'm told. So at this point, we will load our data file. So we're going to put our data in an object we're calling series, and we're going to populate that by using this read CSV file up here. So we're going to say read CSV. We're going to read from this file here called daily min temperatures mini CSV. And then we have a bunch of arguments here that are kind of sort of boilerplate arguments that are often the case. So I'm not going to go into those too much. And then just to confirm what we've got, I'm going to use this print command. And so Python's going to want to know, well, what do you want to print? Well, I want to print the series data, but I only want to print what's at the very beginning. So this series calls up your series data set. And then within that, it's going to say, okay, I just want to apply this head command that's going to look at the top lines. And so you get this. So as we saw in one of the slides, it's basically a bunch of dates, and for each date, you've got a temperature. So pretty straightforward. Now, at this point, this presentation is supposed to be about plotting and graphing. So I'm going to actually do some plotting now. I'm going to start with pretty much your your simplest kind of plot. You can't get much simpler than your basic scatter plot. And so to do that, remember we've already got our series data that we loaded, that we established up here. So down here, again, and this is a little bit redundant, but I'm going to import pyplot from the matplotlib library. And often in Python, what you see is you'll start a command with kind of a root. In this case, the root is series. So you're saying, I'm going to pull up the series data. And then you append various things you want to do to that root. So you're saying, okay, I want to take the series data and I want to do a plot. And then within the plot, you're providing various information that relates to how you want that plot done. So here we're saying style equals, and then quotation marks, GO. And that might look like the word go, but that's not really the way it's intended. In this case, G refers to the color, and O refers to the style of point you want. So G in this case stands for green. You could instead have K for black, B for blue, I think Y for yellow. You kind of get the idea. And the O means that you want the point to look like an O, basically. So it's just a circle. And there are also all kinds of other kind of symbols you can use for your points. I'll go into those in a subsequent graph a little bit. And then the second term here in the arguments is you're saying marker size equals 4. So that number, if you make the number smaller, the size of your marks will get smaller. If you make the number bigger, the size of your circles will get bigger. So marker size equals 1 would result in a tiny little like sort of like pinhead of a point. If you were to make it say marker size equals 20, you'd get kind of big blobby circles, and in this case they'd overlap each other and you couldn't really tell anything apart. So that's what that does. And so you do that and you get your basic scatter plot like this. So, that's pretty functional. Now, in the case of this data set, as you look up here, as you may recall, there were only 2 fields. So when you told Python that you wanted to plot this data, there weren't too many options as far as what they could plot. There were only those 2 fields, and so it kind of knows by default that that first field is going to be the x-axis and the second field is going to be the y-axis. But you might find yourself in a situation where you've got multiple fields of data, and so you need to specify to Python which one is supposed to be the x and which is supposed to be the y. So to kind of try out that scenario and get a feel for how that works, I'm going to import another data set, a data set that's a little bit more complicated. So we're going to start off with some things that might look kind of familiar to you by now. So again, we're importing these libraries or certain parts of the library like the read CSV, the pyplot. Again, you're going to see this matplotlib inline command. And in this case, so okay, we're going to define a data set. We're going to call it mtcars_data. And to get that, we are going to use this read CSV data set again. In this case, I don't have this data on my hard drive. It's somewhere off in the web. So it's on a GitHub site specifically. So in that case, you just give Python the full URL for where to find that data. And it's a kind of a lengthy one. It goes all the way out here to the end here, but that's where it is, and that's where Python can find it. So here, by the way, if you want a comment statement in here, you just have pound followed by whatever it is you want to say. So this is a command I had at one point. I decided I didn't need it, so I just commented it out with a pound symbol. So you've got your mtcars_data. You want to plot 2 particular fields against each other. And in this case, you want to say, okay, I want to use my pyplot. So that capability you import up here, you want to use pyplot. You want to do a scatter plot. And so now you got to tell it what fields you want in that scatter plot. So you're saying, all right, I'm going to go to the mtcars data. I'm going to take the displacement field. I'm going to use that for my x. And I'm going to go to that same mtcars data data set, and I'm going to use this horsepower field for my y coordinates. And then you can kind of jazz things up a little bit. You can say, okay, I'm going to use this pyplot again, and I'm going to use xlabel function to say I want my xlabel to be engine displacement. And then you're going to use pyplot again. You're going to use the ylabel function to specify that you want the y-axis to be labeled as horsepower. And so there you go. You get your scatter plot with that's labeled engine displacement on the x-axis and horsepower on the y-axis. Just a second here while I take a drink of water. I'm not used to talking quite this much. Okay, so moving onwards. Let's say you have a plot and maybe you're writing a report. So, it doesn't necessarily do you any good in that case to have this plot in this JUPYTER file. What you actually need is some kind of an image file that you can actually put in your report that you're writing up. So in that case, here's what you do. Again, some other basic boilerplate here, importing the pyplot. And then you're saying, okay, I'm going to use my series data. and I'm going to plot it. And that gets you to something that looks like this, just a very straightforward line plot in this case. So you want to save that. And so within pyplot, you're going to use what's called the savefig command. And you're going to say savefig, and I want to call this testplot.png. And so whatever you have established as your working directory, Python will take this figure and it will save it as an image file within that working directory using whatever name you gave it. And at that point, you can just import it into, say, whatever document you're working on. So you might have noticed a lot of these figures we've done so far have been a little bit on the small side. They're not exactly postage stamp size, but they're not too much better than that. And so you might very well want to have a figure that is larger than that and therefore easier to look at. So to do that, Python provides a way for that as well. Again, we've got some of our same boilerplate here, importing pyplot. But then within pyplot, you're going to now import something called figure. And you're going to use that in the next line here. You're going to say figure, and then you're going to define some characteristics of the figure you're going to have. So you're saying, okay, figure size equals 12 by 9. So I believe that's in inches, I think. So in this case, you're saying, okay, I want my figure to be 12 inches wide by 9 inches high. And I wanted to have dots, I wanted to have 80 dots per inch in this case. And you know, you're free to use whatever numbers you want to. If you want to have a even more crisper figure, you could make this, say, 200 dots per inch or whatever you wanted to, or if you wanted it to be taller or wider, you could change these numbers as well. And then you do your basic plot again. And now you sort of look here, then look down here, same plot, but it's just gotten considerably bigger. And so, you know, just for good measure down here in the final line of the code for the section, I've decided to save this figure again to my working directory. In this case, I'm calling it bigger testplot.png. So we're making progress. We've got some respectable graphs and plots here, but you know, you might want something that's a little bit more elaborate than that, and Python will certainly allow you to do that. So let's look at this graph here, and I'm going to scroll down and look at this graph here. And these are basically the same graph. It's the same data anyway. They're both line graphs. But you know, you kind of see that this one down towards the bottom here has a lot of sort of extra little details and specifications added in relative to the one that we saw previous to this. So I'm just going to show you how to do that. So, you know, the first part looks pretty much like we had before. But here we get into where we actually create the plot. So we're taking our series data set again. And what do you want to do with the series data set? Well, you want to plot it. And whereas up here, we just said, okay, take series and plot it. We just left it at that. Down here, we're providing a bunch of specifications. So we're saying, okay, in this plot, I want the color to be green. So if you look down here, we have green lines. You're saying marker equals, and this is the caret character on your keyboard, which in Python corresponds to making a triangle. So you see the points are now triangles instead of circles. And you've got all kinds of options as far as what kinds of markers you want. So if you go to this website here, that will tell you your various options for markers. You're saying line style equals dashed. Look down here, and indeed we have dashed lines connecting our various points. And again, there's a website here you can go to that will tell you the various kinds of line styles you can use. Line width equals 2. So this is another one of those cases where a higher number means bigger. So line width equals 2 represents a fairly thin line, whereas line width equals, say, 10 would be a fat line. Marker size you saw before. So again, larger number means a bigger marker. So marker edge color equals B. In this case, B stands for blue. So our markers are our triangles. And if you look at them, the edges are in blue. And then marker face color, that's what's inside the marker. In this case, I said make that white, with W standing for white. And so in this case, the interior is white. So since we got a white background, basically for our purposes, it's transparent. So that's everything we've done so far is graphing two data fields, but sometimes you may have more than that. So I'm going to now import our third data set, the one involving quarterly growth in GDP. So recognize some of the stuff at the top first. You're just importing those libraries you've been using all along. And I'm going to use my read CSV command to read in the file in this GDP growth.csv file, and I'm going to put that in an object called GDP growth. So GDP growth is going to be our data. And at this point, I am creating a figure. That's what the fig stands for, and I'm calling it X. And for the time being, I'm just saying, okay, I'm going to use PyPlot to generate that figure. And it's going to contain a series of subplots. And you'll probably understand in a minute what I'm referring to by subplots, but just bear with me. And the figure size is going to be 15 by 7. So in just executing this one command here, all you'd really get is a box. It would just set aside a box of dimensions 15 by 7, and that would be about the extent of it. But now we're going to start adding stuff to that box. But before we do that, we're going to start kind of extracting the data that we want to graph here. So for my x-axis, I want my x-axis to refer to the various quarters of the year. So I'm going to say my quarters data is going to come from the GDP growth data set. And from that, I'm going to extract the quarter field. There's a field in there called quarter. And I want to extract that as a list. Now, this is kind of important, this toList, because there are various forms that data can take in Python, and you specifically, for our purposes here, want that to be in the form of what is called a list. So we've got this toList appended to the end of this. And then you start extracting data corresponding to the various years. So data 2017 is going to be taken from the GDP growth data set again, and you're going to pull out the CY 2017 field from that data set. And again, you're going to extract it as a list. And you're going to do a similar thing with the data for 2018, 2019, and 2020. So you might remember that when we set up this figure, we decided to name it X. So down here, we're saying, okay, within that X figure, we want to do a plot. And within that plot, we want it to be quarters, which we defined up here, versus data 2017, which we defined up here. And we want a circular marker, and we want it to be labeled CY 2017. And then down here, we've got a few more things. So we're saying, okay, again, within this X figure, I want to set the X label to quarter. I want to set the Y label to read GDP growth in percentage. I want to make a title for this figure called quarterly GDP growth for 2017 through 2020. And I want to provide a legend for this figure. And I want that legend to appear in the upper left. And so here you go. We've got your figure. There's your data for 2017. There's your legend. You've got your title for the figure, your labels for the X and Y axes. So all good. But as I set up here, I wanted to give you an example of how to graph multiple data fields, and I've only graphed one here really. So if you look over here, I'd commented out some of these other commands. So I'm now going to uncomment those and going to run this cell of data again. And okay, well, not sure why that didn't work, but anyway, normally what happens is that in addition to that first line, you will get the remaining lines that show the data for the other fields as well. So let me just see if I can quickly remedy that. Let's see. I'm gonna do a restart and run all here. Maybe that'll take care of it. Yes, and there we go. So that took care of it. So as you can see, we now have the data for showing the quarterly GDP growth for all 4 years. And for those of you who might remember the start of our current pandemic, that was in year 2020. And so, already the first quarter, we actually had a negative GDP growth. And then the second quarter of the year, things got really bad, and we actually had like a negative 30% GDP growth. And then things kind of bounced back kind of dramatically in the following quarter, and then they kind of settled back down again in the fourth quarter. Whereas the other 3 years that we have data for here are all relatively level from one quarter to the next. So before I go on, I just wanted to kind of recap what our MT-CARS data set looks like. So just quick command here, say, look at the head, the top lines for the MT-CARS data. And, again, it's a bunch of cars listed down the left-hand column and things like miles per gallon, number of cylinders, displacement, horsepower, et cetera, listed across the top. So I'm thinking we might now want to try doing a bar graph. And I'm thinking for the bar graph, we might want to graph the average horsepower for cars of 2, 4, or rather 4, 6, and 8 cylinders. Because if you look at this data up here, you might notice we got some cars that are 6 cylinders, some that are 4, and some that are 8. So let's just say we want to do a graph it's a bar graph showing the average number of horsepowers for each number of cylinders. But in order to do that, we need to aggregate this data. So I'm going to quickly explain how to do that. So pandas, as I mentioned before, is good for all kinds of data manipulation. So we're going to be importing the pandas library. And we're going to use a couple of functions within pandas. One's called group by, another's called ag. And so we're going to go into the MT-CARS data set, and we're going to apply this group by command to that data set. So we're going to say, okay, take that data and group it by number of cylinders. So it's going to group together the 4-cylinder cars, it's going to group together the 6-cylinder cars, it's going to group together the 8-cylinder cars. And then we got another term tacked on here that says ag for aggregate. So you're saying, okay, for each one of those groups, the 4s, the 6s, and the 8s, I want to aggregate by taking the mean horsepower. So you're looking at the horsepower field and you're taking the mean within each one of those groups. And then just to confirm that it's doing what I think it should be doing, I got my print command here. And I'm saying, okay, now print out this data set I've just created, and I've named it group by cyl. And so there you go. And you got 4 and 6 and 8 cylinder cars groups, and then a mean horsepower for each one of those groups. Now, if you want to work with this data as output by this function, these mean values are actually referred to as by the name of columns, which is not a very intuitive name. So you might, in this case, want to rename that something that makes more sense to you, that gives you a better idea of what it represents. So I'm going to rename that column just to make it a little bit easier to work with. So I'm going to say, okay, let's go to my grouped by cylinder data set, which is what we have here. I'm going to go to the columns field, which is this second field here, and I'm going to name that mean. So from now on, you can just refer to that as mean. And also, this first column here is referred to as the index. So if you're trying to extract these numbers from the file, from the data set, you've got to refer to them as the index. So in this case, I said, okay, go into the group by cylinder data set, take the index and print it. And so that's what you get. It's 4, 6, and 8. So having done that, we can do our bar graph. So again, the heart to doing the bar graph is going to be your pyplot functionality within the matplotlib library. So you're going to import that. And then you're going to create your mean values. So you're going to say, okay, mean values equals the mean column within group by cylinder data set. And you're going to take those values, and again, you're going to put them in the form of a list. Then the labels, which is basically the y-axis, you're going to take, I'm sorry, it's actually the x-axis. You're going to take the group by cylinders data set again. You're going to grab the index values, and you're going to make it a list. So you might notice that we've got two different ways between this line here and this line here of creating something as a list, and they're both acceptable. There's often more than one way of doing things in Python. So that's just an example of that. So in this case, you created this object, and then at the very end, you added on this toList requirement. And in this case, you kind of established upfront, I want to create a list, and then you specified what you wanted to create it from. So it's just kind of approaching things from kind of different directions, but it results in the same net result in the end. So having established your mean values for your y-axis and your labels for your x-axis, you then say, okay, I'm going to pull up my pyplot functionality, and within that, I'm going to do a bar graph. And along the one axis, I'm going to have labels, and the other one, I'm going to have mean values. So it's going to be labels across the bottom. Mean values is going to be the y-axis. And that's what you get. So you got one bar for 4-cylinder cars, one bar for 6-cylinder cars, and a third bar for 8-cylinder cars. And not too surprisingly, the more cylinders you have, the more average horsepower. That's more or less to be expected. So just a few more examples I want to give you here, and we will wrap things up. I want to do a quick histogram. If you're not familiar with histograms, it's basically a quick way of establishing how your data is distributed in terms of your data values. So again, going to use our old trusty pyplot. Going to import figure again and establish our figure size using that. And then the actual plotting of the histogram is pretty straightforward. You're going to go into your empty cars data set. And within that, you're going to pull out your displacement data field. And having done that, you're going to generate a histogram using this hist term here. And there's your histogram. Pretty easy peasy. Now we're going to try out a box and whisker plot. box and whisker plots are another way of basically showing the distribution of your data. So at this point, you're going to start recognizing some of this. There's your pie plot again. There's figure. There's your so all right. So you've pulled in pie plot. You've imported figure, and you're now going to extract your displacement data as a list. So you're going to say, okay, I want to create a list, and I want to create it from the displacement field in my mtcars data set. And then you're going to establish your figure size again, and then with this final command, you're going to generate your whisker plot. And so it's going to just say, okay, I want to use my pie plot functionality. Within that, I want to do a box plot, and I want to do the box plot using this displacement data. And you get something that looks like this. So if you haven't seen one of these before, this kind of orangish, yellow-orangish line here, that marks your median value for your data. And this box underneath it is the first quadrant below your median. And this next line is the second quadrant below your median. And then conversely, this part of the box north of the yellow line is your first quadrant above the median, and then your second quadrant above the median. And if you had any outlier values that were just like way bigger or way smaller than most of your other data, those would appear as asterisks above or below the ends of these lines here. So there's your box and whisker plot. And one final one, we're going to do a pie plot. Since people often do pie plots, I thought I should at least cover that. And again, you're going to use your read CSV again. You're going to use pie plot again. You're going to want to set your figure size again. So one final data set, and I'm now not sure that I included that in my slides as far as what I was going to be using. But anyway, we are going to be using some data from something called hurricanes.csv. So we're going to pull that in with the read CSV function. We're going to assign it to the name hurricanes. We're going to pull the index from the hurricanes data set, which is that first column. And we're going to put that in the form of a list, and we're going to call it labels. Then we're going to create the hurricanes, take the hurricanes data and put it in the form of a list, and we're going to call that quantities. And then we're going to find something called explode. And if you look at these various triangles down here, they're all kind of in line with each other, but there's one that is kind of offset a little bit. That's what this is going to be used for. So in defining this list, you'll notice that these values are all zeros except for this one where you get a 0.1. Well, that 0.1 is referring to this final slice of the pie here. And if I'd made that 0, it would have just kind of tucked in with the rest of the slices. But since I put a 0.1 in there, it just kind of sits it off to the side a little bit. So again, I'm saying, all right, I'm going to create a figure. In this case, I'm going to call it X1. And I'm going to create this figure by pulling up my pie plot again. And it's going to consist of a series of subplots. So each one of these slices is considered a subplot. And I'm giving it the size for the figure and the number of dots per inch again. And so then within that figure, I'm saying, okay, pull up that X1 figure. I'm going to do a pie graph, and I'm going to graph quantities, and I'm going to apply, for the explode effect, I'm going to apply those explode values. And for the labels, I'm going to use the labels. So in this case, the CY 2020, CY 2019, CY 2018 are all our labels. And then we have this argument here for auto percent equals, and honestly, I'm not sure what that does. So the shadow equals true means we're going to have a bit of a shadow effect in here. So if you look along the kind of left side of our pie chart and on the bottom a little bit, you see kind of a shadow effect. That's where that's coming from. And we're saying the start angle is going to be 90 degrees. So if you look at this as the center of the pie, 90 degrees is up this way. So it's saying, all right, this is where I'm going to start my graphing. So it's going to start from here, and I'm going to graph my first slice of pie, my second slice of pie, my third, my fourth, and go around counterclockwise like that. And then finally, we just do pie plot and show, which actually reveals the pie plot. And so you get your, reasonably attractive pie plot here. So, so we've been at this now for about 50 minutes. I'm not going to keep you here much longer. Does anybody have any questions? As I said, I'm not exactly a master programmer of Python, but I'd be happy to try to answer any questions that you might have. So, just let me know. Okay. I don't hear any questions. Let's see, is there anything in chat? No. All right. So either I told you everything you could possibly want to know about this, or I've totally snowed you. I'm not really sure which one, but anyway, thank you for dropping by today. And I hope you found it informative and a useful presentation. So I wish you all a good afternoon. Bye now.